What's up YouTube, this is Demkeys back again with another Unity tutorial, and today I will be teaching you a game mechanic called run, jump and spin. So first we are gonna make our character walk, and then we'll make the character run, and while running, if the character jumps, then it will spin. So let's begin. Okay, what I have in the scene here is a ground object with a box collider 2D and a couple of other sprites that I placed for background, and our player, which is just a cube, and it has a box collider 2D attached to it. The first thing we need to do is add a rigid body 2D component because we want to give our player physical properties like weight and all that stuff. The next thing we need to do is write a script for the main camera because we want the main camera to be following our player. Okay, one thing to keep in mind, we don't want the camera's Y value to change, we only want the X value to change, so we are going to make sure that all those conditions are met in the script. I'm going to call this camera follow script. Okay, so I think we only need one variable over here, that's public transform, call this player, and then we have to set the position of our camera's transform. So transform dot position equals new vector 2, no, vector 3, and the x value should be the value of player dot position dot x, while the y and z values should be the same as what they are currently. So transform dot position dot y, no, sorry, y, and transform dot position dot z. Let me bring this to the next line so it's easier to read. And then we need to drag our player object into, just a minute, here, into the player transform. Next, we need to create a move script for our player. Only then we can actually see the camera movement taking effect. So I'm going to create a new script in our player object and call this player movement script. Okay, so for now we are going to create only two variables over here. One will be public float move force and the other will be a public float jump force. We won't use jump force now, we'll use it a little later. For now, just move force. Okay, so I'm creating a variable called h, and this is going to so this is going to, sorry, just a minute. Okay, so what we are doing here is we are finding out whether the user is pressing the right key or D or the left key or A, and then we are going to, based on whatever result comes out of this, which will be anything between -1 and +1, we are going to multiply that with move force, and then we are going to use rigid body 2D dot add force and use h's value within add force. So that'll be new vector 2, h on the x-axis and 0 on y. And I need to assign a value to move force. So I guess 50 should be fine. 50 is too much, but okay. Anyways, so now let's run the game and see if the camera script works. Yes, it works just fine. Oops. So yeah, the camera script is working. This is a little high. I need to change this. Okay. So the next thing we need to do is apply a limit to our player's speed, because initially the player should be walking, not running, and 50 is it's a lot of force to apply. So that's going to increase the player's velocity a lot. So we need to add a limit to it. So the first thing we need to do is create a public float variable called x velocity limit. Yeah, okay, that's fine. Okay, and now we'll add an if condition over here. Okay, before I continue, I need to explain something. Now, because the value of h can be between, it can either be less than 0 or it can be more than 0. So I need to create two separate, sorry, so you need to create two separate if conditions. So if the player is trying to move to the left, a different if condition will be executed, and if the player is moving to the right, a different if condition will be executed. So if h is less than 0, this will be our negative value. Then if x velocity limit is, no, not x velocity limit, rigid body 2D dot velocity is less than x velocity limit, then execute this. Wait, something is wrong here. If the velocity is less than, but that is in the case of going right. Here we are going left, so I think it should be greater than, no, yeah, greater than negative, whatever the negative value of the x velocity limit is. So in this case it's going to be 10f, and we need to create one more if statement. So else if h is greater than 0, in that case we are moving in the right direction, then if rigid body 2D dot velocity is less than x velocity limit, which is 10f, then add force to the rigid body 2D. Let's see if this works. Oh, let me add one more variable and call this player velocity, so you can actually see the velocity of our player. This should be a vector 2. Okay, player velocity equals rigid body 2D dot velocity. There's something wrong here. Oh, I should have specified along which axis. Should be fine now. Yep. Okay, so let's play the game. Notice the value over here. It's positive 10 and the speed doesn't increase any more than that, and the same works for negative 10 as well. Negative 10 is when the player is going to the left side. So our player is not going as fast as he was going before. Okay, the next thing we need to do is add a jump script. uh, if input dot get key down, yeah, key code dot space, then rigid body 2d dot add force, new vector 2, and this time you have to apply the force on the y-axis, not x, so that would be jump force. We will set the value for jump force before we run the game. I think 400 should be enough. Yes, this works. Okay, so what do we need to do next? Next we need to make our player run. In this case, the player is going to the user is going to press shift while the left or right key is pressed. Now because we have two if conditions, so again whatever we do over here, we're gonna have to do the same thing over here. I'm sorry, but I haven't been able to think of a better way to do it. I'm sure there must be a better way to do it, but this is the way that I could think of. Okay, so if input dot get key down, no, get key, key code dot left shift, then what we need to do is increase the velocity limit, the x velocity limit, so that our player can actually move faster. That will be x velocity limit equals, say, 30f. Else x velocity limit equals 10f. And then we copy this and paste it in the other if condition as well. Now let's see if this works. Oh, keep in mind, here we won't have the problem of left shift working even when the left or right key is not pressed, because here the if condition is only executed if h is less than 0 or h is more than 0. Basically if h is less or more, then that means either of the keys are being pressed, so we have taken care of that validation. Now let's see if it works. The way to find out if it works is paying attention to x velocity limit. It should change to 30 while we are walking and pressing. Yes, you can see that. And you can also notice the speed. Sorry, I'm getting choppy graphics, I'm not sure why. Okay, let's try this again. So walking and then running. I hope you were able to see it. So yeah, it works. Now you'll notice that our player is able to spin. That's because we haven't checked fixed angle. I'm gonna uncheck it here and set it from the start function. Rigid body 2D dot fixed angle equals true. This will stop our player from spinning. We don't want the player to spin when he's walking and jumping. We only want him to spin when he's running and jumping. The use of doing this is, well, you already saw the player was spinning when he's not supposed to be spinning. So this will stop that from happening. Okay, next we need to, what comes next? Next is, yes, the first thing we need to do is create a flag that'll be a boolean, and we'll call this is running. So this will tell us whether our player is running or not, and we can use that, the value of this boolean, to do things later. When should the value be set? I think this would be a good place. Yeah, is running is equal to true. So basically, while the player is running will be set to true, and once the left shift key is let go of, then is running should be equal to false, because then the player is walking, not running. And we have to make the same changes here. Is running equals true and is running equals false. Now we need to use this flag. Okay. If is running, writing this is the same as writing if is running equals true. So if is running is equal to true, then rigid body 2D dot fixed angle should be false, and rigid body 2D dot add force. Okay, that's the jumping script. Next we need to add torque. This is going to make our object spin. We can add a value of, I think jump force value should be more than enough. It's gonna add a good spin. Else, if not running, not is running, sorry. If not is running, then just yeah, then rigid body 2D dot fixed angle equals true, and just jump. That's it. I think I'm missing something here. Let's run the game and see if this works. Okay, I have an error. Oh, I need to use a vector 3. Can I use something else? Nope. Okay. New vector 3 0 0. We want to add the rotation along the z-axis, not x or y. Should be fine now. Okay, so let's run the game and see what happens. So we are walking, we're running. Oh, wait, end of. Wait, something's wrong here. There is no rigid body. Oops, I forgot to add 2D. Yes, that is why I was getting that error. Because rigid body 2D dot add torque takes only a float, I guess. Yep, a float and also a force mode, but I'm using just a float. Okay, run, jump. As you can see, it works just fine. Whenever we run and jump, the player spins. Let's try walking and jumping. Nothing happens. But when you run and jump, then the player spins. You can see that you need to add a lot of validations to this. One of them being checking the angle of the rotation of the player, because at a certain point the oh, there's another bug. Fixed angle did not. Okay, yeah, there's another bug. So yeah, you get the point. This is how you create this game mechanic. It's a simple way, or maybe it's complicated, I don't know, but it's something for you to build off of. You can modify this code, or maybe after watching this video you might get a better idea. But yeah, this is how you create this game mechanic. I hope this tutorial was helpful. Check out these other videos as well. The video on the top left teaches you about simple enemy AI. The video on the top right teaches you about raycasting, and the video on the bottom left teaches you how to use the interactive clock. I'm also accepting donations, so if you would like to donate some money to support me, you can send it to my PayPal email ID, which is mentioned on the screen and in the description down below. Visit my channel for more videos. Don't forget to like, share and subscribe. Leave your comments below, and I'll see you guys next time.
Is he even still the same? Claiming Lord's boys, but we never seen him main. Not on cover, now on album when he get the chance to hang. Like, damn, 134. Niggas acting like I never been through them doors. Moved uptown and I rocked a little red nigga.